Okay, welcome back, everybody. Now we're going to go on with question number 7. So again, you're taking really good notes, you're writing good steps, and then any tips or tricks or strategies you're putting on the right-hand side of your notes to keep track. Okay, question number 7. This is something you can try on your own, combining a little bit what we did with question number 6 and also a little bit with question number 4. So if you feel good, you want to try it on your own, or if you already had and you're just checking it, go ahead and just pause it for a second and then come on back and I'll show you the steps and the answer. All right, question number 7. Where is the secant equal to 2.5? Again, we're in degree mode and we can use the calculator, thank goodness, because of those decimals. So first thing I would do is recognize that I can't take the inverse of a secant, so we're going to change that to one of our friends. If the secant of theta equals 2.5 over 1, then if I flip both sides, that means the cosine of theta equals 1 over 2.5. And just like in last time, I don't know what 1 over 2.5 is, and it doesn't matter because I'm going to plug that into the calculator in just a second. Here we go, let's take the inverse. Theta equals the cos inverse of 1 over 2.5, and that's a positive number, so I know that if I'm between quadrants 1 and 4, quadrants 1 and 2 for cos inverse, I'm probably going to land in quadrant 1. Okay, we're in degree mode. Let's plug into the calculator. The cos inverse of 1 over 2.5 should give me about 66.4 degrees. All right, that is quadrant 1. That's good. Okay, and we do want positive angles out, right? So that one's a good answer. Now we throw away the inverse for a second and just think, where else is the cosine a positive number? Positive 1 over 2.5. And we know that cosine is positive here in quadrant 1. And you want to take a guess, where else is cosine positive? Yep, right down here in quadrant 4. Right. So the answer that we found was 66.4. So that's this angle right here, just about. And I drew that there. That means the other angle in quadrant 4 is always going to have the same reference angle. So it's also 66.4 degrees down here. But that's not our final answer. We have to take it from 0 degrees. What is that second angle from 0, going counterclockwise? And to find that angle, that's actually going to be 360 minus that reference angle. So really, my second answer should be about 293.6 degrees. Okay, so again, just review the steps. First thing I did is I changed my secant into its new friend of cosine. And if I flip that side, I got to flip the right side. I plugged into the calculator to find the inverse. I knew I was going to land in quadrant 1. And then I got rid of the inverse, and I just think, where else is cosine a positive number? I landed here in quadrant 4, drew the same reference angle as I did, and then figured out from 0 degrees, what is that second angle really? And it's a full circle minus the reference angle. And so I get those two answers. Final answers, how about 66.4 degrees and 293.6? Final answer. You can feel free to plug those back in. I don't know if I'd plug it back into the original. It might be a little tricky, but maybe plug it back in over here and just plug in cosine of those answers and see if you get about 1 over 2.5. Okay, ready for question 8? Question 8 is actually easier than it looks. Let's just double check again. We're in degree mode and we get to use calculator. But like my steps on the right hand side, we can't take the inverse yet because the sine function is not all by himself and isolated. So we have to do that first. So try to move all the furniture around until you get sine theta equals to itself, and then just keep going like we've been doing in previous problems. Go ahead and pause the video now and try it on your own, and I'll meet you back here in a second. All right, welcome back. So to isolate everything, I'd probably move the 2 over by subtracting it, and I'll probably move the 3 by dividing it. So subtracting the 2 first, and then dividing the 3 when I'm done. That means I should get over here that the sine of theta, once he's all isolated, should be equal to 2 over 3. Is that what you got? Great job. Well, let's do our steps. Let's take the inverse. This is sine inverse, which is quadrants 1 and 4, and he's a positive number. So I know I'm going to land in quadrants 1 or 4, well probably in 1 because that's where sine inverse is positive. And when I actually plug into the calculator, the sine inverse of 2/3, not a normal unit circle angle, so we have to plug into the calculator. I get about 41.8 degrees. Great. That is quadrant 1. He is right there, 41.8. So toss out the inverse for a second. Let's think, where else is sine a positive number? And that's actually way over here in the second quadrant. So let's use the same reference angle, 41.8 degrees. But we always have to think from zero, what is that second angle really? And that's going to be 180 minus my reference angle. So my second answer should be about 138.2 degrees. Final answers, let's put them both together here. 41.8 degrees and 138.2 degrees. Steps here, not much different than before, folks. The only thing I did differently is I just tried to isolate the trig function first before I took the inverse. Okay, take a breather. Feel free to pause the video now because number 9 and 10 are much different. Okay, for number 9 and 10, I'm going to open up a new document here, so hold on just a sec. Here we go. This is on the second Discovery Day sheet, getting into 9 and 10. And again, just like you've been doing so well, folks, do write down the examples really clearly with the steps and then some helpful hints or words on the right-hand side. Here we go. Number 9 and 10. If you notice, the one thing that's really different about 9 and 10 is now it's not just theta, it's this 2 theta, or it's a 3 theta. We need to figure out what that means. We're not exactly sure yet, but for now, I'll tell you, this just looks confusing to me, so I don't like seeing a 2 theta. So can we just substitute in something else besides that? I'm going to call that just an x. Okay, so really, this says the cosine of x equals 1/2. Okay, why don't we just use our previous knowledge and try to solve this one before. Now this one actually is on our unit circle, so we don't need calculus on this, and we're also in degree mode. So I'm going to jump ahead. We're going to take the inverse, and our first answer out would be, where is the cos equal to 1/2? And let's say we're in degree mode. I would say 60 degrees. If you want to think where else is cosine equal to a positive 1/2, that's also in the fourth quadrant. Got the first quadrant. And cosine is positive 1/2 in the fourth quadrant. So that'll be over at 300 degrees. Okay, that's great. But that's actually not our answer because we have more to do. Do you notice that you saw originally here, before I scratched it out, that this was a 2 theta? I'm going to give you a hint and tell you that because it's a 2 theta, we're actually going to have to look in 2 circles worth of answers. I'll explain that in a little bit later why that's going to work out. But the first thing you want to do with the 2 theta is recognize that you want 2 circles. 2 theta means 2 circle worths of answers. So in 1 circle worth, you got 60 degrees and you got 300 degrees. Great. But now we have to go through the circle one more time and get those same answers back in the second circle. This just goes back to our knowledge of coterminal, right? So if the first answer was 60, the second time around, if you add a full circle to that, 360, you get 420. So here's another answer. And if you add a full circle to 300, you get 660. Again, why did we do that? Because it's a 2 theta. 2 theta says we need to look into 2 circles worth of answers. So we got our first circle's worth, 60 and 300. And then we found in the second circle, those answers would be the coterminal friends, right? Add 360 to each, and you get 420 and 660. But guess what, guys? We're still not done. All these are equal to x, right? But where did x come from? X came from the fact that we said, we don't like what 2 theta looks like, Mr. B, so we're going to substitute x in. Well, why don't we substitute it back out? If x equals these 4 answers, then let me substitute back in. Then 2 theta is equal to these 4 answers. So I'm just resubstituting the x and the 2 theta back in. Apologies. All right. Oh, but what are we solving for? We're solving for theta, right? We're always solving for angle theta. So quick step. All we got to do is just divide everything by 2, which means we're going to divide everything by 2. Final answers, I'll just put right down here on a list. What is theta equal to? Theta is equal to 60 over 2. 300 over 2, 420 over 2, and 660 over 2. Notice that when I get all my answers together, you notice how they're all within actually one full circle? When we divided by 2, it worked out beautifully, which is why we needed 2 circles worth of answers, so that when we divided by 2, we got it back to 1 circle's worth of answers. Again, we can always check our answers by plugging them back into the original. For example, if I took our first answer of 30 degrees and I plugged it back up here in the top, and we plug 30 in for theta, then the cosine of 2 theta, that's the cosine of 2 times 30, that's the cosine of 60. And if you look at your unit circle, what's the cosine of 60? It is a half. And you can try that with any of these guys. You can try it with any 4 of these and it will automatically work. Okay, let's review our steps, folks. We saw the 2 theta. We freaked out a little bit, so we just substituted in an x to make it simpler, and we solved it like that. But then remembered, because it's a 2 theta, we're going to search in not just 1 circle's worth of answers, but 2 circles worth, and we found those other friends by using coterminal, adding 360 to our first 2 answers. Well, then we resubstituted the 2 theta back in and said 2 theta equals all 4 answers, but we're not solving for 2 theta, we're solving for theta. So we divided everything by 2, and here's my final answer. Question number 10 is a lot like that, but can you see it's not theta or 2 theta, it's 3 theta. How many circles do you think we'll need? And at the end, what are we going to divide by? All right, feel free to pause the video and try it on your own, and I'll show you it in a second. All right, here's question number 10, guys. I'm actually going to jump all the way to the end. In case you got it right, I'm going to show you all my answers here. If you did it right, theta is equal to 10 degrees, 50 degrees, 130 degrees, 170 degrees, 250 degrees, and 290 degrees. We're in degree mode, and all positive answers back out. Let me fix that answer over there. All right, if you did that, bravo, you are done and good to go. Before I show the steps here, what's coming up in the future for the next couple sets of problems that we're going to see, yes, there's more problems in 6.6, we're going to need to know a lot of factoring, guys. And we did that on the algebra assessment at the beginning of the year, and a lot of you fixed all of your factoring mistakes and you're doing great at it. But if you're still having trouble, we need to fix them now. And this is the part where it's really, really important. So the next part of your work module is to do a little factoring practice. So you're going to see a worksheet on RadarNet under Resources Chapter 6 called Factoring Practice. You're going to try about 7 or 8 of those and check your answers and see how you're doing. All right, if you feel like you're done, go ahead and do that. You can stop the video. Otherwise, here's question number 10. All right, so we see the 3 theta and we think 2 things. First of all, 3 theta, so I'm going to have to go through 3 circles worth of answers. That's going to be a lot of answers. And not only that, but we're going to divide all of our answers by 3 at the end. So like we did before, can we just substitute in and not call it 3 theta? I'll just call it an x. So where is the sine of x equal to a half? We can take the inverse, do all those steps, and x equals either 30 degrees in the first quadrant, or where else is sine positive? Second quadrant, so 150 degrees, 150. But that's in the first circle. Let's look in the second circle. So we're going to add 360 to each of those. It's also going to be 390 and 510 degrees. But it's 3 circles, right? So here we go. Another 360. So you're going to add 360 to these previous 2 that we had here. So if you add 360 to those, you get 750 and 870. Whew. That's 3 circles worth. Why? Because it was 3 theta from the beginning here. All right, but this is x equals all these. But x is also the same thing as 3 theta. So 3 theta equals all 6 of these answers. Let me write them out for you really quick. And you can see what we're going to probably do in our last step to get theta all by itself, right? Well, if you beat me to it, go for it. Ready? All right, we don't want 3 theta, we want theta. So we're going to divide everything here by 3. The cool thing is, even though you went through 3 circles worth of answers, once you divide everything by 3, do you see that all your answers are in one circle? That's pretty cool. So that's questions 9 and 10. When you see a 2 theta or 3 theta, you think we got to look through more circles worth of answers and we got to divide by the end. And we can take any one of these guys and plug it back in. For example, if I take the 50 degrees, let's plug that back into the original and see if it works. Let me make some space here so I can see. If x is 50, or theta, sorry, theta is 50, and I plug that in, 3 times 50, that'd be the sine of 150 degrees. And you look at your unit circle, and what's the sine of 150? And it really does work. All right, you got the first set. You've done now the simple problems and sort of the medium sets of problems, and we'll save the tougher ones when we get into class next time. But now, take a little break, guys. You want to do a little factoring practice before we do some more practice problems from 6.6? Feel free. Good job in this, guys. I'll see you soon.